What is it? Elements, right. And the simplest, smallest part of an element is an atom. So take this for example. This is actually the basic unit of diamond. Okay, it's a tetrahedral crystal shape. Okay, so this repeats like a bazillion times, and you have diamond. Okay, each black one is carbon. So if I take the sticks are like chemical bonds. That reminds me of like, you guys ever watch Looney Tunes? I don't know, I can't think of an example, but it's like one of the characters does something and like the wrong end of something falls off, like smashing them on the head or something. Anyways, I like that stuff. Back to this. This is an atom. It's the simplest part of an element that retains properties of that element. So that's what an atom is, the simplest part of an element that retains properties of that element. So atoms are individual circles on paper or on the board, okay? That's an atom. If you take two atoms and chemically combine them, now what do you have? Okay, good. There's actually, yeah, there's some terms I didn't list there. Those are the basic terms. This is a diatomic element, but it's also called, when two atoms come together, it forms this, a molecule. So this happens to be a diatomic element because both atoms are identical. But it's also a molecule because it's two atoms chemically combined. So let's just stick with the molecule. So yes, everything on the board has atoms in it, but these are the only two atoms that are by themselves. So on a regents, on a test, on a quiz, if I give you a diagram, it's like a box with all this stuff in it, and I say which one contains atoms, you can't say all of them. Because what the question really means is where are the individual atoms. It's not going to say individual atoms. Okay? So don't be confused with that. This has two atoms in it, but because they're touching, that's not called an atom. What's that called? That's this. Molecule. So molecules are literally everything up here. I'm going to write it for each one. So molecule, that's a molecule, that's a molecule. So a molecule, and if you say it enough, it sounds really weird. It's like one of those words. Molecule, molecule, and a molecule. So all of them are molecules. If you have at least two atoms chemically combined, it's called a molecule. So that's the basic stuff you need to know going, leaving. Okay, so all that good stuff I just said wasn't getting recorded. Back to this. So, yeah, this is an element because why? Why'd you say that? They're all the same substance, atom, right? It's three identical atoms. So using that knowledge, where are the other elements? They all have to be the same color. Is this an element? Yeah, that's an atom of an element. Okay? What about this one? Yes, that's an element too, because it's two of the same color. These two that are both shaded, also an element. This single atom is an element. In fact, you can't have anything else but an element if it's a single atom. All the single atoms in the world and all these drawings are elements. These two, look up here please, these two, those are diatomic elements. Those are diatomic because there's two atoms chemically combined. So they're diatomic. I don't know if you guys have room to write that, all right, but those are called diatomic. So these are diatomic. Okay, so I'm just going to kind of separate them. Those are diatomic. That's just a single atom of an element, single atom of an element. This is called a what? If this is called a diatomic, this is called a triatomic element. This is triatomic. There's only one triatomic element you'll ever see or read about or hear about or see. I already said see. Ozone, O3. Ozone. Sorry, Max, can you see?
You're good.
Correct. All right, so what are these over here? These are all compounds over here. These are all compounds, okay? All of these are compounds. So they're separate from that. I drew them kind of that way on purpose. So, Laura Griffin, what do you notice about compounds versus elements? What's the difference as far as how we draw them? Like, how are you supposed to know if I draw two things on the board, which one's an element, which one's a compound? Two different colors, exactly. You see two different symbols touching, two different colors, shaded and not shaded, that's an automatic compound. Okay, that's like the red and the yellow. Okay, so that's like the red and the yellow. If I put these together, that's a compound. If I take them apart, that's two elements. Okay, two atoms, but also two elements. That's a molecule, and it's also a compound. So what you're learning today is kind of all the different terminology. That's an atom and an element. That's a molecule and an element. That's a molecule and a compound. So all of these are molecules and all of them are compounds. You can't really be one without the other for compounds. You have to have two touching for a compound. Elements can be by themselves. So this might be throwing a lot at you, but this is covering all our bases, everything you need to know. Diatomic element, what do you call a single atom? If this is triatomic and this is diatomic, what do you call a single atom? So like in the movies, you have surround sound, but what if it was just one speaker? You ever know what that's called? Mono is a prefix. This is called monatomic. This is a monatomic atom, okay? Monatomic element. Monatomic element. So what I want to do now is erase this and then draw some examples of things you might have to identify, okay? So, and then we'll end with that. And I do have a worksheet. I know it's the weekend, but that's how we're doing it. All right. So, draw 3 boxes. This is kind of how you would see it on a regents or a test. I'm going to draw 2 pictures in 2 diagrams in 2 of them, and then the third one you're going to draw a picture. Okay? And the last thing, before I do this, imagine these boxes are sitting on the table right here, and we're looking at it. Imagine it's a real thing. Why? Well, if I draw a solid in that box, where would the solid be in real life on the table? At the top of the box or bottom of the box? Bottom. So remember that. What would a gas look like? It would fill it up. And in a liquid, would be on the bottom, just the particles might be a little more spread out than a solid, right? So we learned all that already. We're going to apply it now. Okay. So here we go. So there's that one. That one. And okay, so you're gonna draw over here. Ooh, let's get crazy. Draw iodine mixed with argon. No. Even better yet, water vapor. Let's see if you're understanding how to do this. But I am going to get chopped off by the bell. You know what? We'll do that together because I don't want you to have to redraw it. So just hang tight with that one. Okay. So while you're copying that, let me give you your homework. We are going to go over that, though. We do have a couple minutes. So this might be a little confusing, but that's okay. Sometimes we gotta try and figure things out a little bit on our own. That might help you learn it. So that worksheet's due to, not tomorrow, Monday. Monday. Okay, let's see if we can at least get these real quick before the bell rings. Can anyone tell me, first of all, is this box a mixture? Yes, because you have this substance and this substance. What's this substance with the shaded circle? What would you give me a name for that? An atom? Good, what else? An element. So we have a monatomic element, or we have atoms, mixed with, what do you call this? Diatomic. What physical state are both of those in? Gas. So here's what I want to write underneath it. It's a mixture, and I am going to get cut off, but that's okay. We'll finish it Monday. Mixture of gases. We have a monatomic element and a diatomic element. So we're done. I apologize for going over. Don't forget that worksheet. Do the best you can. It might be a little confusing, but I think you have enough information to do a decent job on it. And that's it.